All right. Good morning, everybody. So I hope you can hear me well. Um, so last time we talked about elementary matrices and tiningnan natin paano natin masusulat yung Gaussian elimination process, at least yung version niya without pivoting as a matrix multiplication equation. So tingnan natin paano natin nako-convert o ano yung elementary matrix that can give us the same effect as those three types of elementary row operations that we discussed in the previous module. All right. So, and then we went on through the process. We considered one example. We revisited example 6.1, I guess. Tapos, tiningnan natin paano natin i-convert yung elementary row operation solution that was performed in Module 6 into the matrix equation you see in equation 7.3, right? So just a quick recall, yung mga isabays dito, mga elementary matrices, ito yung mga matrices na nanggaling doon sa identity matrix, tapos pinerform natin yung mismong elementary row operation that we performed into the augmented matrix A. All right? So para makuha natin ano yung pang pre-multiply dun sa matrix A para ma-recreate natin yung entire Gaussian elimination process. All right? Tapos remember, ang goal natin dito makakuha ng isang matrix factorization para sa matrix A. Kasi may mga applications na mas okay na uh, i-manipulate natin yung coefficient matrix A kasi baka naman gagamitin natin siya ng paulit-ulit sa pagsosolve ng isang linear system. Tapos para makatipid tayo ng number of operations, papalitan na lang natin yung right-hand side whenever the information becomes available because Gaussian elimination is still a very expensive process. It is of order big O of n cubed, yung kanyang complexity. So, kailangan nating magtipid as whenever possible para maging mas efficient yung computation process. Okay? So I hope pinag-practicean nyo na to. I hope you tried multiplying the 6 matrices that I identified in our solution earlier. Tapos may gumawa ba? Or wala pa rin kayong time para gawin yung mga extra shenanigans on the side natin? So, yun yung supposedly gusto ko makita sa exercise 7.1. You just multiply the 6 matrices that we defined in our solution last time. Meron bang gumawa? Let me see. Can anybody describe how E6 looks like? Oh, yes, Christine.
Sir, tinry ko po siya sa matrix calculator po. And hindi ko po nakuha yung upper triangular po. Feeling ko po meron po kasi 'di ba po sa E2, ay hindi ko po sure kung E1 or E2, meron pong negative 33/4 po. Ang nakita ko po dapat po negative 3/4 lang po. Para po, yung una ko po ginawa, yung first 3 po muna, para po makuha ito pong 4000 po. Tapos dapat po negative 3/4 po yung sa may E1 po, hindi po 33/4.
Okay. Yeah, thank you, Christine. Tama. Hindi ko siya napansin last time. So, doon pa pala sa module 6 may typo na pala doon, no? Pero when you change it to negative 3/4, okay naman yung matrix. You get yung E6 times E5 times E1 ay naging lower triangular ba?
Hindi rin po. Feeling ko, di ko po sir mahanap kung saan po may problem sa arithmetic po. Pero hindi ko po nakuha. Yung ang problema lang naman po is yung sa row 2 lang po. Hindi ko po nakuha yung 7/4 po. Or di ko din po sure baka na-typo lang din po ako sa pag-input ng data. Pero ayun, hindi ko po nakuha.
Okay, thank you, Christine. Let me check that. Pero yeah, supposedly, bakit 33/4 to? Hindi natin to napansin ng huling module, no? Kasi example to sa module 6. Kasi we want to eliminate the 4 here, right? Sa second, hindi. Let me see. Gusto kong i-eliminate ito. Alright? So gusto ko itong i-eliminate. So kailangan itong pivot entry, i-multiply ko ng 4/3. Tama, no? I-multiply ko dapat to ng 4/3 or negative 4/3 para ma-cancel yung, minus 3/4. Tama. Sorry, maaga pa sa sa body clock ko. So, minus 3/4 yung multiplier niya, dapat mamumultiply siya ng 4 para maging -3, maka-cancel ito. So yeah, this should have been -3. Thank you, Christine. Edit ko yung module 6 and module 7 later. So dapat to ay -3/4. So dapat ito ang E1 ay maging -3/4 to. Sorry. So dun sa elementary row operation, dapat maging -3/4 yun. So dapat ito mabago. Tapos ito ay, nasan si E1? Si E1 ay ito. Dapat mabago rin yan. Tapos, let's see. Problema yung 7/4. This will be multiplied by -3/4. So we'll have -9/4. Idadagdag ko siya sa 4, 16. So I think it should really be 7/4. So medyo may problema lang dun sa dun sa multiplier ko dun sa elementary row operation. But I hope you get the idea. So minus the typos na we had or yung sa wrong solution, siguro typo to, naging 33/4. Pero yeah, but keeping those aside, I guess you'll get the idea. All right, kung paano siya pinoform. Okay. Tapos, supposedly, if everything went well, when you carry out this multiplication, dapat ma-create natin yung upper triangular matrix U. Okay? But this is quite different dun sa final output na gusto natin. Ang final output natin gustong makuha ay A equals LU, right? We are basically factoring the matrix A into the product of a lower triangular matrix L and an upper triangular matrix U. Okay? So we'll see today how we can do that, and hopefully we'll have time to illustrate how the LU factorization can be utilized in order to solve system of equations, or actually not just a system of equation, but a sequence of systems of linear equations having the same coefficient matrix. Okay, na hindi mo kailangan paulit-ulit gawin yung elimination process. All right. Now, as a quick exercise, you can try answering exercise 7.2. Okay? Tapos ang kagandahan dito, katulad ng ginawa ni Christine, madaling i-verify kung tama yung solution nyo. Kasi usually, parang sequential yung magiging problems natin. Katulad dito sa exercise na dinagdag ko na sa module 7. Ano? So usually in series yung mga questions. So ibig sabihin yung result mo sa isang calculation will be the input to the next calculation. And you don't want to run the risk of having a wrong result being passed on to the rest of the process kasi magiging mali na yung mga sagot mo dun sa subsequent problems, right? So madali naman siyang i-verify. So katulad ng ginawa ni Christine, carry this multiplication out just to make sure that everything is in order. Otherwise, pwede nating i-reconsider yung solution natin. Katulad ng gagawin ko later para sa module 6 and module 7. Okay? But essentially, yeah, kailangan natin pa itong i-modify ng kaunti para makuha yung LU factorization. Okay, but essentially the takeaway from that is the Gaussian elimination process can be represented by pre-multiplication by a bunch of elementary matrices. Now, the example that we have seen really only required row translators, yung pangatlong klase ng ating elementary matrices. And we will limit our discussions for now dun sa mga matrices that are reducible to an upper triangular matrix by way of only using row translators. So hindi natin i-consider yung mga may pivoting strategies at saka yung may other elementary row operations required, because that will require us to have actually not an LU factorization, pero ang mangyayari sa kanya ay LU equals permutation matrix times the matrix A. So instead na A equals LU, ang factorization na makukuha natin ay PA equals LU, where P is a permutation matrix, and there are preconditioning techniques that you need to perform. And I think that is more advanced, kaysa dun sa Math 175, and it should be tackled in a numerical linear algebra class. So medyo specific lang, i-consider natin yung pagre-reduce ng mga ang titingnan lang natin ay yung mga matrices that are reducible to an upper triangular matrix using only row translators. So, medyo matrabaho yata, at least on paper, yung pagko-compute ng elementary matrix na kailangan natin para ma-recreate yung effect ng ng pangatlong klase natin ng elementary row operation, right? Which is adding to another row a scalar multiple of another row. But actually, a quick calculation will give us a nice form para dun sa elementary matrix na yun kasi kailangan natin mag-develop ng mga shortcuts. So you can verify na kung gusto kong palitan yung kth row ng identity matrix by the kth row plus a scalar multiple of the lth row, all right? So para makuha si matrix E, yung matrix E na elementary matrix natin para sa row translation na ito, ganito lang yung itsura. Yung diagonals niya ay puro ones pa rin, okay? Kasi hindi naman mababago yung diagonals nun. So, identity matrix tayo, di ba? Tapos, yung entry doon sa kth row at lth column ay equal dun sa multiplier C na gusto nyong pang-translate. Tapos, everywhere you'll have a zero entry. So, just to illustrate how the equation 7.4 and 7.5 works, halimbawa, ano ba yung gagawin natin? Halimbawa, meron akong 3 by 3 identity matrix. Alright? So, 3 by 3 identity matrix, gusto ko tong isulat as, gusto kong palitan yung second row by second row plus 3 times the first row. Alright? So, naging pivot ko dito sa operation na to ay yung first row. So, mangyayari dito ay, so 1 pa rin to, 0, 0. 1 pa rin yung diagonals kasi hindi naman maapektuhan. And we know that this will only affect the second row. So, magzi-0 na yung nasa third row, right? Sige, tanggalin ko muna yung 1 dun sa gitna para makita natin kung ano talaga yung mangyayari. Well, we are multiplying row 1 by 3 and adding the result to the entry in the second row. So it's going to be 3 plus 0. That will be 3. And then this would be 0 times 3. So that's 0 plus 1. So it's going to be 1. And then 0 times 3 plus 0, it will be 0. So essentially, dahil yung second row, pinalitan ko lang by a multiple of the third row. So yung entry sa second row, first column, noong elementary matrix na makakapag-recreate ng elementary row operation na to ay equal dun sa scaling constant. Alright? So kung ganito yung format, pag-denote nyo ng elementary row operation, yung pinalitan mong row, siya pa rin yung row number, yung row number na ginamit mong pang-translate, siya yung magbibigay sa'yo ng column number kung saan maninirahan yung scalar C doon sa elementary matrix. Right? So, para hindi nyo kailangan paulit-ulit i-perform ito para lang makuha yung elementary matrix para sa row translation. Okay? So, basically, that's what equation 7 point, 7.4 and 7.5 are telling us. Okay? So with that in mind, okay, madali nang maghanap ng elementary matrices para sa row translators. Sasabi nga natin, limitado na yung discussion natin sa mga matrices na row translators lang yung kailangan para maging upper triangular matrix. Okay? Now, another bit of information, kapag ka meron kang lower triangular matrix na ang diagonal entries ay puro 1, ang tawag natin doon ay unit lower triangular matrix. If it's an upper triangular matrix with ones as the diagonal entries, then they are called unit upper triangular matrices. Okay? So basically, pwede nating i-postulate o pwede nating sabihin na oo nga, yung lahat ng mga row translators natin, sila ay mga unit lower triangular matrices. Okay? So basta pagka lower triangular, na 1 yung main diagonal, ang tawag natin doon ay unit lower or upper triangular matrix. Okay? Now, with all those new information in, let's see how we can use equation 7.3 in order to get an LU factorization. But in order for us to do that, we'll need some results from linear algebra, which, luckily for us, I'll skip the proofs. Alright, kasi feeling ko yung proofs dapat Nasa linear algebra na siya. So I'll just quote the results. Maybe some of you don't have a linear algebra yet, either Math 120 or AMAT 105. Just let me know kung may mga terminologies na hindi familiar para pwede ko siyang i-discuss, because otherwise I'll assume that you know rudimentary linear algebra. Okay? Now, Theorem 7.1 tells us that elementary matrices are always invertible. Laging may inverse ang elementary matrix. At makikita natin yung proseso na yon by just, or kaya natin i-compute yung inverse ng elementary matrices by just undoing the action of the elementary row operation on the identity matrix. Siguro mapapahapiawan ko yung proof ng 7.1 when I present to you the proof of 7.3. Okay? Pero yon, lahat ng elementary matrices ay invertible. Tapos, the product of, or basically maybe before I go to theorem 7.2, maybe I'll say something about the inverse of a product. Okay. Halimbawa, meron akong matrix A na square matrix, matrix of the same dimension si B. Tapos alam ko yung product AB ay invertible. Does anyone remember? And saan equal to? Kapag sure ako, si A at saka si B ay magkasing laki, parehas silang square. Tapos alam ko yung product nila ay invertible. So how can I compute AB quantity inverse, or the inverse of A times B? Tandaan niyo ba to from linear algebra? Or na-encounter niyo na sa linear algebra? Talaga? Hindi pa? Or nahiya lang kayo sumagot? Yeah, thank you, Ezekiel. Yeah, he's right. It's B inverse times A inverse. And this works in general sa kahit anong field. So yung mga nag-modern algebra dyan. You just need to be very conscious about the ordering, all right? Dahil ang matrix multiplication ay hindi commutative, laging strict. Ganito yung gagawin. Pag i-invert ng product, i-invert mo bawat isang factor, pero dapat in the reverse order yung multiplication ng mga inverses. So AB inverse is equal to B inverse times A inverse. Okay? And we will use that to further modify, to further manipulate equation 7.3 later. Okay? Tapos ano pa yung theorem ko nilagay dito? The product of two unit lower triangular matrices is also a unit lower triangular matrix. And I think it can be proven by explicitly multiplying two arbitrary unit lower triangular matrices. Tapos makikita nyo yung product ay unit lower triangular din. Okay, but just keep that in mind. Okay, and probably try to write proofs for them. Okay. Then, let's see 7.3. Ito yung isa pang kagandahan about unit lower triangular elementary matrices. Kasi sila bilang, let's see. Okay, yeah, this is fine. The inverse of a unit lower triangular elementary matrix is also a unit lower triangular elementary matrix. Ang haba nung theorem, no? So, ito yung kagandahan sa mga unit lower triangular matrices. Tapos, ito yung mag-allow sa atin na makakuha ng madaling LU factorization mula dun sa equation 7.3. Now, I wrote here a proof, okay, na dumadaan sa elementary row operations para magka-idea kayo in case gusto nyong i-prove yung 7.1 and 7.2. Alright? So, ngayon, magko-consider ako ng isang unit lower triangular elementary matrix. And basically, unit lower triangular elementary matrices are actually your row translators. Okay? So, halimbawa, si matrix E ay yung unit lower triangular elementary matrix, which is a row translator that we obtained by translating the kth row of the identity matrix by C times the lth row of the identity matrix. Okay? So, yan yung nangyari. Tapos si K ay greater than L. Kailangan ko to kasi ang usapan natin na unit lower triangular elementary matrix CE. Okay? Tapos, di ba, ang gusto nating makita ay may inverse ba si E? Alright? So, meaning, we want to find a matrix E inverse such that E times C inverse is equal to the identity matrix. Alright? So, paano ka makakabalik sa identity matrix? So, this action is represented by E. Alright? To get E inverse will simply undo what this elementary operation did in the previous step. Kailangan ka lang makabalik sa identity matrix. Alright? So if that is the case, then it's easy to see na, kung gusto kong makabalik mula kay mula kay E, pabalik sa identity matrix, kailangan ko lang i-restore yung kth row niya pabalik dun sa kth row ng identity matrix. And I can do that by simply reversing the action that we did in the previous step, wherein we transform the identity matrix to E. So pag nagsimula ako kay E, tapos pinalitan ko yung kth row ni E by its kth row minus C times the lth row, then we will get back the identity matrix. So basically, etong row operation na to ay ang inverse ng row operation na ito. Alright? Then let me apply this to the identity matrix. Tapos yung resulting elementary row yung resulting row translator ay tatawagin kong matrix big F. Alright? So basically, si big F yung elementary matrix that you will obtain by performing this elementary row operation on the identity matrix. Okay? Tapos para makita na inverse siya talaga, pag in-apply ko kay identity matrix, etong dalawang row operations na to, babalik ako sa identity matrix. Alright? Kasi nga, inverses lang yung elementary operations na pinerform ko. Okay? But in the language of pre-multiplication of elementary matrices that we learned in the previous meeting, right? Alam natin na yung identity, okay? Pag nag-pre-multiply ako sa kanya ng row translator corresponding to this elementary matrix, then nag-pre-multiply ako dun sa sagot by the elementary matrix from that ERO, from that elementary row operation, the product will give me the n by n identity matrix. All right? So, and then this tells us na, identity matrix, wala yung effect sa multiplication. So essentially, matrix F times matrix E ay equals sa identity matrix. Right? Then you can do the same thing, but reorder etong dalawang elementary row operation. Pag pinagpalit mo yung order nila, mapapakita mo naman na si EF ay equal kay identity matrix. So basically, we are seeing here that when we multiply F and E to each other, regardless of the order, we always get the identity matrix back. So that means only one thing, that F is the inverse of the matrix C, right? But we have seen that F is a row translator, and we know that a row translator is always a unit lower triangular elementary matrix. So that means, really, totoo yung Theorem 7.3. Okay? So does the proof make sense? Okay. And you can employ the same strategy para ma-prove yung 7.1 and 7.2. So, hindi, yung 7. Ano ba yung madali dito? Yeah, I think yung 7.1. Kasi generic yung sinabi niya, elementary matrices are invertible. So gawin nyo lang yung same process. Nagsimula ka sa elementary matrix, makikita mo na ang inverse ng isang elementary matrix ay yung matrix na manggagaling dun sa pagpa-perform ng elementary row operation that can undo the action of the given elementary matrix. Alright, so parang ganun yung mangyayari ron. Yung 7.2, direct multiplication lang ng dalawang arbitrary unit lower triangular matrices. Okay. And I think with this in mind, we can now get an LU factorization finally para sa isang matrix A. So suppose that we did the Gaussian elimination, and then we translated all of the elementary row operations into pre-multiplication of elementary matrices EM, E sub m minus 1, E sub 2, E sub 1, and so on. All right. Remember, the goal is to get an LU factorization. So ang goal natin, A equals LU. Meron na akong U rito. Ang problema ko ay ito, may panira rito. Kailangan matanggal ko muna ito. All right? But the thing here is, bawat isang E ay isang elementary matrix. And by Theorem 7.1, elementary matrices have inverses. All right? So ibig sabihin, yung inverse ni E1 nag-exist, inverse ni E2 nag-exist, hanggang inverse ni EM. So basically, that is sufficient to conclude that the product of the E's is invertible. Right? So ibig sabihin, mag-exist yung inverse na ito. And then if I multiply that inverse, okay, to both sides of the equation, all right? So ang gagawin ko, magle-left multiply ako. Mumultiply ko rito yung inverse ng mga e's. So ibig sabihin dito, magmumultiply rin ako ng inverse ng mga e's. Okay? So ito yung makukuha ko. So magiging identity yung product dito, tas dito meron lang masisingit yung inverse. Alright? So basically, nag-multiply tayo to the left by the inverse of the first M matrices that you see on the left-hand side. So we'll get this. Tapos, gagamitin ko yung formula na binigay sa atin kanina ni Ezekiel na, product yan. Kukunin ko yung inverse. Alam ko, invertible bawat isang factor na nasa product. So, kukunin ko lang yung yung inverse ng bawat factor, tapos i-reorder ko yung multiplication. I'll do the multiplication in the reverse process. Okay? Then we are hoping that this guy will qualify as our L. The only requirement is that L should be a lower triangular matrix. Okay? But we know that E1 is a row translator, so it's a unit lower triangular elementary matrix. Ang inverse niya ay magiging unit lower triangular elementary matrix din. So bawat isa rito ay unit elementary unit lower triangular elementary matrix. Tapos by theorem 7.2, we know that the product of lower triangular matrices is also lower triangular. So bawat isa ay lower triangular, so ang product na yan ay lower triangular. So ibig sabihin, we are fine because the product na meron tayo rito would be a lower triangular matrix and hence giving us the desired factorization. So ito yung isang paraan ng pagkuha ng LU factorization ni matrix A. All right? Now, in summary, what you need to do to get an LU factorization, or one way to do it, is to first perform Gaussian elimination dun sa matrix A. Yung Gaussian elimination na yon will give you the matrix U. Tapos, ang gagawin mo, i-retrace mo ano yung mga elementary matrices na corresponding doon sa elementary row operations that we needed to perform in order to get the upper triangular matrix U. Tapos, kokolektahin mo yon in the proper order, take their inverse, or take their inverses, multiply their inverses, that will give you the matrix L. Okay? Tapos, ang problema nga lang doon, sige, later na lang yung problema. So, tingnan muna natin isa pang example sa 7.5. So, binabaan ko na lang 3x3 kasi sumabit na nga ako dun sa 4x4 na example kanina. Thanks again to Christine. Alam ko na kailangan ko siyang i-edit. Okay? So, mas maliit na lang. 3x3 na lang na system A. So, na matrix A. So, ang gagawin ko, Gaussian elimination. And it's important that you note the elementary row operations that you perform. Okay? So, Gaussian elimination, nakuha ko, matrix U is this guy. Alright? Ayun yung final result ng LU ng Gaussian elimination. Tapos ngayon, kukunin ko yung elementary matrices that led us to the upper triangular reduction of the matrix A. Alright? So, unahin ko to. Row translator ito. So, alam ko yung row translator ay puro ones pa rin yung nasa diagonal. That's why we know that the row translators are all unit lower triangular elementary matrices. Alright? Tapos alam natin na pagka ito yung operation, yung second row, first column no identity matrix ay papalitan ko lamang nung multiplier dun sa translator. So that's why the entry here on the second row, first column, is equal to the constant scalar negative 3 halves. Siya si E1. Tapos ito si E2. So si E2, magsimula ka uli. Yung diagonal entries ay puro 1 kasi nga alam natin ang row translators ay lahat unit lower triangular elementary matrix. Tapos in-scale, tinranslate natin si row 3 by a multiple of row 1. So that means the elementary matrix corresponding to this operation has the entry on the third row and first column equal to the scaling constant 1/2. And there you go. Third row, first column. Okay? So hindi naman pala mahirap yung pagkuha ng elementary matrix. Kailangan mo lang i-note ano yung multiplier doon sa row translation na ipa-perform mo, sino yung translate mo kasi siya yung magbibigay ng row number, tapos kung sino yung pang-translate, siya yung magbibigay ng column number. And finally, for the last row translation, so yung third row, second column ng identity matrix ay mapapalitan ng multiplier na 9/13. So this will give us E1, E2, and E3. So in effect, we can say na, okay, ito yung kailangan kong i-pre-multiply kay matrix A para makuha si U. So ang itsura nun ay ganito, E3, E2, E1 times A equals the upper triangular matrix. Okay? Tapos kung medyo duda kayo, well, ipa-multiply nyo lang to sa matrix calculator nyo o kay MATLAB o kay Python. So kayang-kaya nyo yan. Check nyo, nakuha ko nga ba si U? Right? Para rin na-check nyo every step of the way yung solution nyo. Right? And then since we want an LU factorization, we'll get the product, or actually we get the inverse of this product, but that is basically just the inverse of E1 times the inverse of E2 times the inverse of E3. And this is our matrix L. So mukhang dapat tama to kasi minano-mano ko to. So ito yung E1 inverse, E2 inverse, E3 inverse. Tapos, yeah. Ito pala yung, hindi, nakita na pala natin to dun sa proof, no, kung paano nag-i-invert ng isang row translator. Kaya ako nga pala pinesent yung proof ng Theorem 7.3. Now, if you look at E1, ito yung itsura ni E1. Okay? Pero remember, ang inverse ni E1 ay i-undo lamang yung action ni E1. So here, to get E1, we translated the second row of the identity matrix by negative 3/2 times the first row. Yun yung dahilan kung bakit meron tayo. Sabi ng Theorem 7.3, yung inverse niyan madali lang. Gawin mo lang, i-translate mo lang uli si row 2 by 3/2 times the first row. Diba? Yung C at saka negative C, babaguhin mo lang yung multiplier na scalar. So, ibig sabihin yung inverse ni E1 ay kaparehas na kaparehas ni E1 except that this entry, the scalar entry in the row translation should be negated. So, yung inverse ni E1 ay E1 na E1 except that yung scalar multiplier ay pinalitan natin yung sign. Okay? Ganun din si E2. Si E2 kasi tinranslate si row 3 by 1/2 times the first row. Pero para ma-undo yun, makabalik ka sa identity matrix, edi i-translate mo lang ito by 1/2, by negative 1/2 times the first row. And that will give you the inverse of E2, which is basically E2, except that the entry on the third row's first column will be negative of what it originally was. Right? Tapos ganun din yung E3. Ang inverse niya, ayun lang. Okay? Naging negative lang yung multiplier na ito. Okay? So yan yung mga shortcuts na pwede nyong gawin kung balak nyong gawing mano-mano yung exercise kasi hindi naman siya ganun kahirap. Alright? So na-compute ko na yung mga inverses. Pwede ko itong ipa-matrix calculator ulit. Take the product. I'll get this guy. Tapos, yung sagot dito, i-multiply ko dun sa natitirang matrix, I will get this. Okay? So therefore, I found an LU factorization. This is my L, this is my U, and then you can double check when you take the product, then you'll get the matrix A back. So ito si L, ito si U. Okay? So far, it seems that the bulk of the work is finding the E's, all right, yung elementary matrices, tapos pagko-compute nung inverse nung product nung mga E's. All right? So yun lang yung naging problema. Yun yung mahaba rito. E1 taking the product E1 inverse, E2 inverse, and E3 inverse. Pero may shortcut dito. All right? So yung shortcut dito ay paano makuha yung lower triangular matrix? Actually, oops. Ano nangyari? Okay. Paano natin gagawin yung shortcut? Okay. So, para makuha yung L, actually, you can prove it rigorously, pero i-describe ko na lang sa inyo yung process para madali nyo makuha si L. Alright? So, i-take note nyo lang talaga yung elementary row operations na kailangan nyo gawin para makuha si matrix U. Alright? Tapos, yung matrix L, kung susundin nyo tong process na ginawa ko, so yung matrix L ay unit lower triangular. So alam mo na yung main diagonal niya ay puro ones, sa ibabaw nung nung main diagonal puro zero na yung laman. Okay? Tapos yung mga laman doon sa ilalim ng main diagonal ni matrix L, sila lamang yung negation ng mga multipliers doon sa elementary row operations na ginamit nyo. Alright? For instance, look at this guy. Alright? We translated the second row. Okay, we translated the second row by -3/2 times the first row. Okay? So remember, inverse yung kinukuha ko. So ibig sabihin, yung matrix L ay magkakaroon na entry sa second row, first column, that is equal to the negative of that multiplier. Okay? So again, ano yung translate? Yun yung row number. Kung ano yung pinang-translate, siya yung column number. Kunin mo yung negative ng constant, yun yung entry dun sa lower triangular matrix. Alright? So, second row, first column ni L will be equal to positive 3/2. And there you go. Okay? And then second ERO na ginawa natin, translating the third row. Oops, alam ko na yan. Nag-translate ako ng third row, so ang consideration ko ay nasa third row ni L. Anong pinang-translate ko? First column. So ibig sabihin, ang entry dun sa third row, first column ng matrix L ay equal sa negative ng scalar, so I will have -1/2. And then lastly, you can guess that the entry on the third row, second column of the matrix L will be equal to -9/13. Okay? So ganon, yung shortcut nung pagkuha nung LU factorization. Alright? Is that okay? Any questions so far? Yan yung gagawin niyo sa Exer. So magtanong na kayo ngayon kung may problema. Okay, so kung wala naman, yung process na yung dinescribe ko, siya yung nakasulat dito sa module. Alright? So, mas madali kasi siyang explain minsan kesa sa isulat. Now, question. Okay. Exercise first. Yes, Ezekiel.
Hello, sir.
Hi, yes.
Sir, tanong ko lang po kung yung algorithm ba ay mag-a-apply sa kahit anong size ng matrix.
Yes, kahit anong size ng matrix as long as row translation lang yung ginagamit mo. So, dapat hindi ka nagpipivot para mag-work itong method na to. Alright? So, basta kung type 3, lahat ng elementary row operation, mag-hold to kahit ano pa yung size ng matrix.
Okay po. Thank you, sir.
All right. So you can practice on it and verify yung results sa example 7.5. Meron siya dyang factorization. Okay. Now question. All right, sir. So marunong na tayo mag-LU factorization. Paano ko naman yan gagamitin para mag-solve ng linear system? Okay. So basically, we assume we already have an LU factorization for a matrix L. Tapos for the matrix A. Then I want to solve the equation AX equals B using the LU factorization. So ganito yung mangyayari. And you will see bakit gusto mo na lower triangular times upper triangular. Okay, so A is equal to L times U. So replace A by L times U. Okay, everything is good. And then we will use the associativity of matrix multiplication. Associative ang matrix multiplication kahit hindi siya commutative. But associativity is fine for us, right? So it just means we need to change the grouping without changing the order. Okay. So let's just see if the matrix dimensions agree. Si Li n by n, si Ui n by n, so yung product ay n by n. So si X ay n by 1, so that makes sense. So the product would be n by 1, which is our matrix B. That's fine, okay? Tapos, associative daw ang matrix multiplication, so pwede kong i-group yung U at saka X muna. And that's fine kasi associativity solely lang yung ginamit ko. Hindi ko kailangan yung commutativity kasi wala naman akong binagong order. Okay? But let's see if it really is well-defined. Si Ui n by n, si Xi n by 1, so yung product nila ay well-defined and it will be what? It would be an n by 1. So ito ay n by 1. Si Li n by n, so yung product niya ay n by 1. So everything is fine so far. Is fine so far based on the multiplication requirement for the dimension of the matrices. Okay? Tapos ang gagawin ko ngayon, mag-i-introduce ako ng panibagong variable. So I will let U be equal to Ux. Tapos si U, alam natin by our analysis earlier, ay n by 1. So basically, papangalanan ko lang yung Y. Right? So essentially, our original equation will now become Ly equals B. So ngayon, nagkaroon tayo ng dalawang equations. Si Ly equals B at saka si U equals Ux. So ito yung isa-solve ko instead na Ax equals B. Tapos sabihin niya, sir, hindi ba tayo nagkakalokohan? Isa lang yung system na given, Ax equals B. Pero bakit ngayon gusto mo mag-solve ng dalawang equations, y equals ux at saka ly equals b. Actually, solving these two equations would be much easier than straightforward aiming for solving ax equals b. Kasi si L ay lower triangular na. So kung si L ay lower triangular na, kailangan mo lamang dito ng forward substitution. Okay. Kasi, makikita natin yan mamaya. Forward substitution dito, tapos ito, kailangan ko na lang ng back substitution. Okay. Kasi nga, lower triangular to, so ibig sabihin, puro 1 yan, 0 yan, dito ka lang may mga non-zero entries, times y1, y2, y3. So, mas madali mong masasolve si y1. Makukuha mo si y1 gamit yung unang row, tapos pag alam mo na yung value ni y1, makocompute mo si y2 using the second row, and so on. Kaya forward substitution yung tawag dito. So, I promise that y can easily be solved using forward substitution. Tapos pag alam mo na si y, edi makukuha mo na yung right-hand side dito. Tapos ito, upper triangular, natutunan natin mula sa Gaussian elimination na madali lang siyang isolve. Kailangan mo lang ng back substitution. Alright? So siguro mas madali itong makita if we'll consider a quick example. Okay, example 7.5. So, yeah. Ito yung coefficient matrix. Tapos binigyan na tayo ngayon ng right-hand side. Sa exercise 7.5, sinabihan ko kayo na i-verify itong LU factorization na to para kay matrix A. So I hope that will fan out correctly. So paki-double check na lang. So kung yan yung LU factorization niya, okay? So I will let y be equal to ux. So ibig sabihin yung equation 7.7 magiging ly equals b na lamang. So una kong isosolve si y. Alright. So yung lower triangular matrix ay ito. Kinopy-paste ko siya rito. Tapos yung solution y vector, tawagin ko siyang y1, y2, y3, and y4. Equate ko siya kay b na given sa problem. I'll have this. Okay. And you will see na, okay, this guy multiplied by this guy, or actually when I say multiplication ng row at column, ibig sabihin dot product yon. So this guy times this guy will be y1 equals 2. Oh, yes, nakuha na natin yung unang y1. Tapos yung y2, this guy, times this guy. Remember, pag nagmo-multiply kayo ng 4 by 1 ng 1 by 4 at saka 4 by 1 matrix, alright? So, ito ay magiging 5 halves times y1 plus 1 times y2. Kaya ako nakuha ito. Tapos equal siya dito kay negative 3. Pero alam ko na kung saan equal si y1. So, pwede ko itong palitan ng 2, tapos i-transpose siya dun sa kabila. So, essentially, this is what I'll get. I'll have negative 8 for the value of y2. Tapos alam ko na si y1 saka si y2. So, ngayon, ito, i-multiply ko nito, makukuha ko itong mahabang equation na ito. Pero no problem because we know y1 and y2 already. So, plug their values in, and then you can easily compute for y3, and you'll see that it's equal to 10. Okay? Tapos ganun din dun sa dulo. Essentially, you'll get 6 over 13. Sana tama yung fractions ko rito. Alright? So now we know what the vector y is. The vector y is given by this guy. Di pa tayo tapos kasi ang sinosolve natin ay si x. Ang meron pa lang tayo ay si y. Meron pang isang process na kailangan. Remember, we let y be equal to ux. Kasi ito na yung kailangan natin para ma-solve si x. So si u, siya yung matrix galing dun sa LU Factorization. Yung unknown vector x, tawagin kong x1, x2, x3, x4. Kopyahin ko yung value ni y mula dun sa solution kanina. Alright? So, yan yun. Tapos, ito na yung parang ginagawa natin sa Gaussian Elimination. Alright? So, magba-back substitution na lang tayo. Magsisimula ako dito sa dulo, 71 over 13, x4 equals 6 over 13. If I do the manipulations, I'll get, sana tama, negative 117 over 71 as my x4. Tapos, kaya ko itong, so ito ay minus 117 over 71 na. So, solving for x3 will be easy. We'll have 5x3 minus 4 times negative 117 over 71 equals 10. And that will give us negative 300. Sorry, baligtad pala. Yung x4 pala ay 6 over 71. So, siya yung value dito, 6 over 71. Tapos, back substitution ulit, ang x3 ay 7334 over 355, and so on. Alright? So, but I trust that you know the back substitution already. Ito yung ginawa natin sa Gaussian elimination. Actually, yung kung mapapansin nyo sa Gaussian, ito yung relation ng Gaussian elimination sa LU factorization. Pag naggawa ka ng Gaussian elimination, di ba, nare-reduce natin yung system sa augmented matrix U, which is exactly this guy. Yung right-hand side niya actually ay yung vector Y na nanggaling dun sa, na nanggaling dito sa previous step natin, sa pagsosolve ng Ly equals B. So essentially, yung Gaussian elimination talaga ay isang nakatagong proseso ng LU factorization. Alright? Kasi nga, nagsimula ka sa A augmented by B. Pag nag-elementary row operations ka, makukuha mo ay U, Y. Si Y ay yung nasa right-hand side na to. Kaya ito rin yung back substitution na kailangan yung gawin kung nag-Gaussian elimination kayo. Right? Pero ang kagandahan dito sa LU factorization ay kapag ka paulit-ulit mong gagamitin yung matrix A as the right-hand side of your, as the coefficient matrix of a linear system, hindi mo na kailangang gawin yung Gaussian elimination ng paulit-ulit. Kasi ang mangyayari lang, papalitan mo lang yung B dito. Okay? Pag meron ka nakuha na B, okay, alam mo na to, forward substitution para makuha yung mga y1s, which is actually what you would have gotten in the augmented part of the Gaussian elimination, pero ayaw mo ang paulit-ulit gawin yung Gaussian elimination. So forward substitution will give you what the vector y is, tapos mag-back substitution ka na lang para ma-solve si x. Tapos pag may dumating ka na naman na bagong right-hand side para sa ax equals b, hindi mo na kailangan mag-Gaussian elimination para makuha yung vector y. Ang kailangan mo na lang gawin, forward substitution and then backward substitution, which is not that very expensive. Okay? So, ganun yung ipapagawa ko sa inyo sa lab excerpt. I hope I can borrow 5 to 7 more minutes if you don't mind. If you need to go, you can just just watch the recording later, the latter part of the recording. But yeah, any questions? Nagbe-make sense ba yung process? Kaya niyo na ba itong gawin sa lab excerpt? Kahit walang sumasagot. Kakayanin. Kasi wala kayong choice, ano? Tama, Charles. Yung example 7.6, kailangan ko palang baguhin. Hindi, siguro. Kailangan ko bang baguhin? Kasi ginawa ko siyang homogeneous equation. Kasi tinamad ako mag-isip ng right-hand side. Alright? So, kasi ang sabi rito, papalitan mo lang daw yung matrix B. Papalitan mo lang itong right-hand side na to. Gusto ko lang i-illustrate na mas madali yung LU factorization. Kasi pag meron ka ng LU factorization, hindi mo na uulitin yung Gaussian elimination. Alright? Pero ang nilagay ko dito ay homogeneous system. So, ibig sabihin yung right-hand side ay 0, 0, 0, 0. Pero if that is the case, then puro zeros lang yung mga exabytes na makukuha nyo. Alright? So, probably I'll need to change this para hindi maging trivial yung solution. And then, okay. Medyo marami pa pala. Pero sige, tingnan ko na lang kung ano matatapos ko. All right. Now, the LU factorization seems to give us an efficient way of solving a bunch of linear systems with the same coefficient matrix. But the question is, kailan merong LU factorization? Kasi ang problem natin ay hindi lahat ng matrices ay may LU factorization. Kapag ka si A ay isang matrix, kahit ano yung size niya, pero kung siya ay reducible into an upper triangular matrix using only row translators, then there is an LU factorization for the matrix A. Alright? Pero merong mga matrices na walang LU factorization kahit sila ay invertible. Halimbawa, itong 2 by 2 matrix na to. Yung 2 by 2 matrix na yan, meron niyang inverse. Okay? Pero yung reduction niya mula kay A papunta sa isang upper triangular matrix will require us to interchange the first and the second row. That's the only way that we can reduce it to a matrix U. Kailangan talaga natin yung row interchange. Alright? So, ibig sabihin, fail na. Hindi na siya row translator lamang para ma-reduce sa U. Okay? So, kapag ka mayroong row interchanges na nagaganap, that might bar us from having an LU factorization. Okay? Kasi, sige, tingnan natin by contradiction. Kunwari, meron siyang LU factorization. Okay? Tapos, ang LU factorization na yun, ganito yung itsura. Lower triangular times upper triangular. And let's see what would be the issue. All right? So, let's check. So, kung yan yung matrix, madali lang naman mag-check kung tama yung LU factorization. So, multiply this. You'll get U11. Let's see. Ano ba yung minultiply ko? Okay. Multiply ko to at saka ito. So, I'll get L11 times U12 plus 0 times U23. So, ito ay L11 U12 lamang. Tapos, saan to equal? Siya yung equal dito sa entry rito. So, equal siya kay 1. Alright? So, since L11 times U12 ay equal kay 1, so, ibig sabihin, hindi pwedeng mag-0 si L11 at saka si U12. Kasi pag may isang nag-0 sa kanila, hindi na, 0 na yung right-hand side. Hindi na siya magiging 1. So, we need to force that those two factors are non-zero. Okay? The same thing goes for the multiplication of the second row and this guy. Yung product nito ay U11 times ano yung tamang product? L22. May typo na naman yata ako. So this should be, this should be L21 Kasi ito yung multiply ko. U11 times L21 ay equal kay 1. So that means U11 and L22 should not be 0. Non-zero sila. And everything is still fine until I get this guy times this guy. So I'll get U11 times L11 ay dapat equal kay 0. Right? So yun yung product na yun. Pero, contradiction yon. Bakit siya magiging contradiction? Kasi alam ko si L11 ay hindi 0. Tapos si U11 ay hindi rin 0. So imposible na yung L11 times U11 ay maging equal kay 0. So that means really this matrix does not admit an LU factorization even though it is reducible to an upper triangular matrix by an elementary row operation. So yun lang yung siste. Hindi lahat ng matrices ay may LU factorization. Okay? Now, maraming necessary and sufficient conditions to guarantee that a matrix has an LU factorization. A sufficient condition is what we mentioned earlier, na kapag ka siya ay reducible to an upper triangular matrix using only row translators, then sure tayo, meron siyang LU factorization. May iba pang criterion, pero kailangan natin ng linear algebra concepts para at least ma-statement lang yung mga conditions na yon. So kaya limitado yung kaya kong ibigay sa inyo na pang-check kung merong LU factorization ang isang matrix. Now, yung pinakamadaling nakita ko ay kapag ka daw yung leading principal minors ng matrix A ay non-zero. Okay? Which is basically ang daming terms na nangyaring bago, no? Actually, isa lang pala, pero it's quite a mouthful. The leading principal minors should be non-zero. Ano yung ibig sabihin natin ng leading principal minors ay non-zero? So, ito lamang yung determinants. Familiar ba kayo guys sa determinants? Or hindi pa talaga? So kung hindi pa kayo familiar sa determinants kay MATLAB, pa-compute nyo na lang yung determinant ng matrix. I think that yung kanyang syntax, ano? So kung meron kang matrix A11, A12, A13 and so on, A21, A22, A23, A31, A32, A33 and so on. And so on, and so on, and so on, and so on. All right, yan yung itsura niya. N by N siya kunwari, right? So para ma-check kung meron kang LU factorization, kunin mo yung principal, yung leading principal minors. Ano yung leading principal minors? Siya yung mga determinants nung increasing square matrix coming from the right-hand corner, the upper left-hand corner. So kunin mo yung determinant nitong 1 by 1 matrix na yan. Yan yung unang leading principal minor. Ano yung determinant ng A11? Kapag siya ay hindi zero, we proceed. Pag nag-zero yan, sure ka na wala siyang LU factorization. Pero kailangan mong gawin to sa lahat ng leading minor. Ano yung pangalawang leading principal minor? Ito, yung 2 by 2 na. So A11, A12, A21, A22, computin mo yung determinant, check if it is 0 or not. If it is 0, then fail na. Wala siyang LU factorization, you can stop. But if the determinant is not equal to 0, then you go to the next leading principal minor. Ano yung susunod na leading principal minor? Yung 3 by 3 na anchored doon sa first entry ng matrix. So check muli yan, tapos 4 by 4 minor, 5 by 5 minor, 6 by 6 minor hanggang makarating ka kay matrix A. Pag dun sa mga minors na yon, walang naging equal kay 0, then sure ka na meron siyang LU factorization. Okay? And it's easy to see with that theorem that the matrix A here doesn't admit an LU factorization kasi yung kanyang unang minor ay equal kay 0. Kasi ang determinant ng 1 by 1 ay yung sarili niya lamang. Right? So, yun lamang yung pang-check para doon. And I think we can stop there. Okay. I'll stop by just saying that ano yung sinabi ko rito? Okay. Sige. I-note ko lang. Sorry, super overtime na. para lang matapos ko yung topic na to, right? So okay, so hindi lagi nag-exist ang LU factorization. Tapos ang set of matrices ay hindi unique factorization domain. So ibig sabihin, hindi unique yung factorization na pwede nating makuha. So that means there could be more than one LU factorization for a given matrix. So dun sa example natin kanina, ito ay isang LU factorization which is obtained by the process that we just discussed. All right? So ito yung resulta ng proseso na diniscuss natin. Pero may iba pang algorithms para sa LU factorization. And one of those algorithms will give you this LU factorization. You can verify that both of them or both of the products are equal to A. However, obviously, this L is different from this L. So meron dalawang magkaibang LU factorization para sa isang matrix. But it doesn't matter, even if you have two different LU factorizations, you are guaranteed to get the same solution to the system. Kahit ito yung gamitin mo or ito yung gamitin mo para i-solve si AX equals B, walang problema. Okay? Now, so dahil magkakaiba pala sila yung mga LU factorization, it will be beneficial to give a name dun sa algorithm na ginamit natin, dun sa proseso na diniscuss natin ngayong umaga. So, ang tawag dun sa, actually, dun sa process na ginawa natin ay Doolittle factorization ng matrix A. Now, the Doolittle factorization or the Doolittle LU factorization of a matrix A requires that the matrix L is a unit lower triangular elementary. Hindi. Siya ay dapat ay unit lower triangular matrix. So, kapag ka ang LU factorization mo gave you an L that is or that has 1 and the main diagonal, ang tawag doon ay Doolittle factorization. Okay? May isa pa, kapag ka naman yung upper triangular, yung puro ones, so makikita nyo yung lower triangular ay hindi na unit kasi meron ng non-equal kay 1 dun sa main diagonal. So hindi ito Doolittle. So dito, ang nangyari naman, yung unit matrix ay yung upper triangular. So meron kang unit upper triangular matrix. Ang tawag naman dito ay yung Kraut factorization. Okay? So probably I leave the Kraut factorization as a reading assignment for you guys. Sige. Dahil hindi ko siya diniscuss, tapos reading assignment siya, para may kabuluhan yung reading assignment nyo, siya na lang yung ilalagay ko sa problem set 2. Alright? Magbibigay ako ng isang matrix, ipapa-Kraut factorization ko siya sa inyo. Yun na yung computational part ng problem set 2. Right? And the material for the Kraut factorization is given in this module. So nandito na actually yung formula. Ginawan ko na siya ng algorithm para dun sa Kraut factorization. And I guess I also gave you an example over here ng Kraut factorization. So everything is here. So pakibasa na lang siya in advance kasi expect na sa problem set 2, ito yung computational part. So I'll give you a 4x4, ipapa-Kraut factorization ko siya sa inyo. Okay? Is that good? Oh, umuo na kayo kaysa mahirap yung computational part, ano? All right, so ito yung exercise for Monday. Okay. Sorry, super overtime na, but let me just say a couple of words here. I gave you a coefficient matrix A, 4x4. Tapos hanapin niyo yung Doolittle factorization. You can do the Doolittle factorization following the process that we'll lay down today. Use elementary row operations to reduce it to a matrix U. That matrix U will be your upper triangular matrix in the LU decomposition. And then take note of the coefficients in the row translations because they will be the entries in the unit lower triangular matrix L. So once you have performed the LU factorization, the Gaussian elimination here, you will be able to get the LU factorization ni A. Tapos pag may LU factorization ka na, isolve mo itong system na to using that LU factorization. So ito, mapapalitan na ng LU. So all you need to do is forward substitution, tapos backward substitution, then you will get the solution C para sa system na to. Tapos gusto ko lang ipakita or ipa-experience sa inyo bakit mas maganda to kaysa paulit-ulit na nag-Gaussian elimination. So, kung ano yung C na nakuha nyo na sagot dito, siya naman yung magiging right-hand side dun sa number 3. Tapos gamitin nyo uli yung LU Factorization para ma-solve naman yung bagong system. Yung system na AX equals C. Now again, this is sequential in nature. So kung ayaw nyo mag-propagate yung kung feeling nyo ay may mali or gusto nyo i-check kung tama yung sagot nyo sa bawat step kasi kailangan nyo yun sa next step, do the sanity checks along the way. Una, magkakaroon ka raw ng LU factorization, edi gawin mo, pa-multiply mo sa matrix calculator yung L times U. Check mo, equal ba siya kay A? If yes, then you proceed. Okay? Proceed ka sa susunod. Okay, forward substitution and back substitution, you'll get a C. All right? Pero dahil si C ay input kay number 3, you want to make sure that you have the right C. Otherwise, mamamali na yung number 3 mo. So what you can do is to ask a matrix calculator to check AC. Si AC by equal dito. If that is the case, then you're good. Tapos, saka ka pumunta sa huli. So dito, forward substitution ulit, tapos back substitution. Alright? Tapos, bago mo i-submit kay Canvas, i-check mo ulit. Yung nakuha mo bang solution, pagka ni-left multiply ko ng A, alright, ang sagot ba ay si C. Alright? So yun yung mga sanity checks na pwede nyong gawin along the way. Okay? So I think that's it. I guess I think I already updated module number 7 in Canvas to include the exercise. All right. So possibly I will upload another update para i-correct yung typo na nakita ni Christine. All right. Not only in module 6 but also in module 7. I'll just send you guys an email once I have updated all of those both of those modules para tama na yung magiging final copy nyo. Kasi baka ikalat nyo yan, tapos mabro-broadcast sa buong mundo yung typo na nagawa ko. Alright. So, yon. Any questions? By the way, may mga nagtatanong nga pala, can you share the modules with anyone? Dahil ako naman yung author ng module, I allow you to share it with your friends or whoever. Okay? I think education should be for all. Nagawa ko na naman yan. So, okay lang na ikalat nyo yan. Kaya lang yun nga, lagyan nyo lagi ng disclaimer na yung teacher ko dyan mahilig sa typo. So, take whatever is written with a grain of salt. All right? Okay. Any questions? So, ngayon pa lang pwede nyo nang i-download yung Module 7 para dun sa exercise. Pero wait over the weekend para dun sa corrected version. Alright? Ang i-correct ko lang naman ay mga typos. Alright? So, thank you for allowing me to go 20 minutes over time. I apologize, but thank you for bearing with me. So, D2L, makita-kita tayo on Monday, hopefully with your questions about XR 3.2. For the rest of you guys, let's see each other again on the lecture on Wednesday. Until then, keep safe, guys. All right. All right. Nice question, Ezekiel. Kailan ko i-upload yung 2.2 and 3.1? I'll upload it by the end of the day. All right. So siguro before 11:59 tonight, i-upload ko yung answer key ng 2.2 at saka 3.1. All right. Pero ang gagawin ko kasi parang hindi pa lahat nakakapag-submit, ang gagawin ko ay i-upload ko ulit siya kay Canvas pero password protected ulit. Kasi email ko lang lahat na nakapag-submit ng Xer, i-email ko yung password. Okay, para hindi ma-tempt yung classmates nyo na buksan yung answer key. Tapos yung mga nag-submit sa akin via email ng 2.2 at saka 3.1, paki-message ako, paki-email ako or message ako na i-share ko sa inyo yung password. Okay? Kasi kay Canvas kasi automatic na kaya kong i-filter kung sino yung mga nakapagpasa tapos sa kanila ako magsisend ng email. So kung nag-send kayo ng mga exers via email, pa-message naman ako or pa-email ako na, sir, kailangan ko yung password. Okay? Tapos PSA pala, bago tayo talaga maghiwa-hiwalay, kung kayo ay magpa-practicum for the coming mid-year, pakisagutan yung survey form na in-email ko sa lahat. Magpo-post din ako mamaya pagkababa natin ng call ng post sa Facebook page ng MathDiv. So, pakisagutan na lang kung magpa-practicum kayo this coming mid-year. Alright? So ito na talaga. Bye guys. See you next week.